Good morning, students. In the previous topic, we learned about speed. Today, we'll learn about uniform motion and non-uniform motion. What is uniform motion? Uniform motion means when an object is moving along a straight line with a constant speed. It is said to be in uniform motion. Okay, for example, let us say that a car is moving. Okay, a car is moving and it is covering 5 kilometers. Okay, it is covering 5 kilometers in 10 minutes. Okay, then it is covering 10 kilometer in the next 10 minutes, that is 20 minutes. Okay, then it is covering 15 kilometers in 30 minutes. So what is it? You can see that it is moving with a constant speed, isn't it? 5 kilometers it has covered in 10 minutes. 10 kilometers it has covered in 20 minutes. 15 kilometers it has covered in 30 minutes. So you can see that every 10 minutes, isn't it? 10 minutes, 20, 30. In every 10 minutes, the car is covering how many kilometers? It is covering 5 kilometers. So that means this motion is said to be in uniform. That means this car is moving in a uniform motion. Clear, children? Whereas what is non-uniform motion? Non-uniform motion means when it is not covering equal distances in equal interval of time. That is called as non-uniform motion. So for example, let us take another example. For example, a car is covering 5 kilometers. Let us take in 10 minutes. Then what will happen? Sometimes there may be an obstruction, or there may be some speed breakers. So it may cover the next 10 kilometers, okay, maybe in 22 minutes. Then it is covering 15 kilometer in next 29 minutes. So here you can see it's not uniform. It is not covering equal distances in equal interval of time. So this kind of motion is said to be non-uniform motion. Okay, usually in Indian roads, children, not only in Indian roads, anywhere uniform motion is not at all possible, because you see, if you look at Indian roads only, there may be in between the road, there may be so many animals may be there. Sometimes dogs may come, sometimes cows may be there, sometimes speed breakers are there. So if you are moving in your own car, you may have to apply brake so many times, isn't it? So it is not possible to move with a constant speed. So uniform motion, whenever we are moving, we are always moving in a non-uniform motion. That means we are not covering equal distances in equal interval of time. So that is the difference between uniform motion and non-uniform motion. Now let us come to the next topic, that is measurement of time. Okay, now in measurement of time, that is in this section, we will study about simple pendulum. Okay, let us see what is a simple pendulum. You can see the figure here. This is a simple pendulum. Okay, so what does this simple pendulum consist of? The simple pendulum consists of a metallic ball or a piece of stone. You can see here. Okay, a metallic ball here, a metallic ball or a piece of stone suspended from a rigid stand. You have got a rigid stand here. Okay, this is a rigid stand, a rigid stand, and this piece of stone or the metallic ball is suspended with the help of a thread. You can see here, this is a thread, and this metallic ball is called as the bob. Okay, what is it called? It is called as the bob. So whenever a simple pendulum is moving, and how does it move? You all know that. See, this is at this position, it is at rest. Okay, so when We have to move a pendulum. You all have seen a pendulum moving, isn't it? I hope that you must have seen the clocks with pendulum. How does a pendulum move? It starts moving. It goes to A, it goes to B, then goes to A, then it comes back to B. So what kind of motion is it? Can you tell me, children? This kind of motion is called as oscillatory motion, isn't it? Or a pendulum, it also shows periodic motion. You can see the time period is fixed. You must have noticed in a clock also, the clocks which have got pendulum. How does it move? Tick tock, tick tock, tick tock, isn't it? So that means what kind of motion is it showing? It is showing a periodic motion, isn't it? So now this pendulum is said to have completed one oscillation when the bob, okay, starting from its mean position. This pendulum is at rest. So this is the mean position O. Okay. So now what happens when this pendulum moves from A to B and then back to O. So this position, it has completed one oscillation. Clear, children? So this is called as the one oscillation. See, again I will explain you how. For example, if we take the pendulum to one extreme position, okay, so this is moving, this is the mean position, it has moved to A, okay, from A it will move from one extreme position to, it will move to this extreme position B, and then again when this comes back to A, okay, it has completed one oscillation. So I hope, children, that this is clear to all of you. So what is one oscillation? One oscillation is this, from here to B and from B again to A. Okay, one. This is one oscillation. Okay, and whatever time is taken by the pendulum to complete one oscillation, from A to B and again back from B to A. Okay, so whatever time is taken by the pendulum to complete this one oscillation, it is called as the time period of the pendulum. Okay, so in this topic you have to study only these two main things. One is the oscillation. Okay, oscillation. One oscillation is from the mean position to one end and then again back to the original position. That is one oscillation. And what is time period? The time taken by the pendulum to complete one oscillation is called as time period. Okay, the change in the displacement. Now what is displacement? Displacement means, see, for example, if this is the pendulum, okay, the bob. Now if you take this bob to this from here, okay, from here to here, or even if you take it from here, okay, till here, if you take it, still, so this is the displacement. At the first position, what was the position? We took it till here and we left it. Okay, and again if we take it till here, still the time period will be same. So this is the displacement. In the first place we displaced it till here. Even if you take the pendulum's bob till here also, okay, even if you take it till here also, still the time period will be same. So that means the change in displacement, okay, the change in displacement, first it was here, then you had pulled it till here. So even if there is a change in displacement, but the time period of the pendulum will remain same. Clear, children? I hope this much is clear to all of you. Thank you.